right, so here we go. I'm going to give you guys, it should only be about 3-4 minutes here. Here we go. Try that one on your own. See if you can do it. Anybody see bisects or midpoint? Don't even think about putting halves of equal quantities in that reasons column. Okay, let's roll. Let's see where people stand here. Don't overthink it, please. Look at your proof statement. How do I get to the givens? Look at the proof statement. How do I get to the givens? Mark your diagrams, get in that habit, hash marks. What do I need to do to these two to get to AC? Got to put them together, right? They're getting bigger, so I got to add. And most of you guys said, all right, if I'm going to add, I've been through this before a ton of times. If I'm going to add, how many pairs do I need? 2. That's what Mr. Carlino gave me. Perfect. Let me show you. I'm going to add them now. AB plus ED is the same as if I added BC and DC by addition. And are you guys getting in the habit now, after I write addition or subtraction, automatically next one's going to be substitution with the proof statement plugged in? Okay. Questions from you guys? Yes?
Can you also say AB plus BC is congruent to CD plus ED?
AB. Oh, I messed that up, didn't I? No, that's my fault. Thank you, V. I messed that up. Mine should be AB plus BC. Yep. How about I add the right ones up? One jab. There we go. Much better. Thank you. All right, all good? Okay, we feeling all right? Because as you guys can see, I'm going to add a new fact up there today, and it's in pink because these are all facts dealing with angles this week. All right, all facts were dealing with angles, which means bad news. Our proofs get slightly longer now. Okay. All right, let's roll. Let's jump right into this. I'll let you guys set up your statements, reasons, write in your givens, mark your diagram. You guys know how a proof starts out now. Remember when you guys took your picture of your first one? That seems like forever ago. And I'm just going to walk around making sure you guys have the markings in the right spots before we start. I should see at least a couple right angle symbols, guys. ACB. A lot of you guys are not putting your right angle symbol there. ACB is a right angle. So we should have a right angle symbol at ACB, along with a right angle symbol wherever you're going to put with those perpendicular lines. What is ACB? See that angle in the middle letter always tells you where you are. So ACB, ACB, you should have one going right there. Okay, a little bit nervous here. Again, you guys know where angle ACB is? AC, trace it, ACB. The middle letter always tells you where the angle is. All right, a lot of us are missing this on our diagram. This right here is a right angle, ACB. Everyone, ACB. Follow the letters. Now let's talk about the perpendicular lines. A lot of you guys had right angles in the correct spots there. Where should I have right angles if CD and AB are perpendicular? I know lines that are perpendicular form right angles. Where should you have right angle symbols? Name the angles where CD and AB meet. 4, Via, where should I have more right angle symbols?
You should have a right angle symbol angle CDA and CDB.
Yep, perfect. I'm just going to put one at CDA for now. All right, we know there's one right next to it. Okay, everyone all right with the markings on your diagram? Okay, again, you could have a right angle symbol on the other side. That's fine. All right, look at what you're trying to prove. Why is ACB and ADC congruent? Well, look at it. Look at it. Look at them. What are they? Look at the diagram. What did we put at ACB and ADC? What are both those angles? Right angles. So should they be equal? They're both 90? Okay, we can talk about it, but now the question is, how do I write it correctly in my statements and reasons? Are we all in agreement? Right angle and a right angle. They have to be equal. They're both 90. How do I write that in my statement? I'm going to use a new fact called all right angles are congruent to go in the reasons. But here's, whoa! It's not a two-step proof. It's not a two-step proof. If you're going to use all right angles are congruent, you better tell me both angles are what type of angles? Right angles. You better tell me they're both right angles before you tell me they're congruent. Do we know ACB is a right angle? Where did I tell you that? In the Gibbons, right? In the Gibbons. We know ADC is a right angle because we marked it on the diagram, but did it get into the proof? No. This is where you make your money and earn your points. You may put it on your diagram. That doesn't mean squat to me. I don't look at your diagram. This is in our proof, right? ACB, right angle. Is this in our proof that ADC is a right angle? No. So it's got to go in first. Angle. ADC is a right angle. If you're going to tell me two right angles are congruent, you better tell me they're right angles first. And you guys know the reason. We've used it on day one when you guys were making conclusions. How did I know this is a right angle? How do I know that's a right angle? Lisa, you got a choice? Perpendicular lines do what, everybody? Form, make, whatever, right angles. Okay, perpendicular lines form right angles. Many times, kids beautifully mark it on their diagram, but forget to put it in their proof. This is what I grade. Make sure it goes in. Okay, do we now know both angles are right angles? Okay, now you can tell me they're congruent. Once you state both of them are right, then you can tell me they're congruent. ACB congruent to ADC. And here's our new reason, only reason of the day today. All right angles are congruent. No addition, subtraction needed here. Just saying two right angles are congruent. Questions? Anything from you guys? Okay, we're going to step it up a little bit now. We are stepping it up with this next one. Okay, you guys go ahead. I'll give you a minute, minute and a half. Write everything in, mark everything you need on your diagram. All right. Let's see what we marked here. I can tell that some of you guys are struggling here finding angles. You got to get in. At this point in the year, if you can't find where angle ABC is, you got to get some help here. Okay, got to get some help. Being honest with you. So you should have an arc mark at ABC, and you should have an arc mark at FGE. Everyone's all right. Next, I see perpendicular lines, which says to me, oh, I should have right angles somewhere. Where? Where AB and BD meet. So I look at where AB and BD meet. They meet at angle ABD, this one right here. So I should have a full right angle at that ABD. Where should my other right angle be? Wherever FG and DG meet. Make that a little bigger right there. There you go. So that's what I was given. Are we ready? Guys, can we find those angles? Yes, no? Am I going too fast and just assuming things I shouldn't? I get nervous when people can't find angles at this point in the year. We need, I'm going to do this in green, DBC, this angle, congruent to DGE, this angle right here. Somehow I need to get those congruent. Everyone, do you see bisector or midpoint at all in this proof? Anybody? Me neither. So get halves of equal quantities. You're desperate if you're throwing that in there. You're desperate. No shot. Look at your diagram. How can I use what I've marked to get to those angles? And this is nothing, guys, I'm not showing you anything new. I want you to use anything we've already used, except halves of equal quantities. How can I go from that diagram and that right angle and that given congruent angle to the one I'm trying to find right now? What do I need to do? That's the question right now. What do I need to do to get to those green angles up there? Using what you've already marked. What's it look like I can do? Come on, dig deep, everyone. Dig deep. Nothing new. Don't start throwing terms we haven't used. Got it, Zach? What do you think? Throw out something out there.
Subtraction.
Guys, take the right angle right now. Remove that congruent angle. What's left? The one I need, right? The green one? Does everyone see that? Take my right angle. Get rid of the one I gave you. You see the one that's left? This is subtraction. All right, stop. Okay, it's subtraction. Got it. How many pairs do I need to subtract? 2. Look at my givens right now. How many pairs of equals do you have in the givens? Ooh, 1, right? But now the second pair is not coming from reflexive anymore. What are you guys going to subtract these angles from? Romeo, what are you going to subtract these angles from?
The right angle.
Everyone agree from the right angle. So what do you need to tell me about the right angles before we subtract? They're equal to each other. So that's what I need first. But what did we just go over in the previous proof? You can't tell me they're equal until you tell me they're what? Okay, again, you did a great job on your diagram, but did it get into my proof yet that they're right angles? Nope, go ahead, write them in. Right angle ABD and angle FGD are right angles. Why? Why are they right angles? Why do we mark them on the diagram as right angles? What told us they're right angles? Adrian, what told us?
There's perpendicular lines.
There you go. Perpendicular lines form right angles. Guys, get used to that reason, right? Anytime you tell me they're right angles, that's probably going to be the reason. Are you ready to subtract yet? I'm not. Why can't I subtract? I'm not ready to subtract yet. Why not? How many pairs do you need to subtract, Emma? 2. I still have that one. It's sitting in the givens. That's it. You still need to tell me the right angles are what? Congruent, and that'll give you your second pair to subtract. Angle ABD congruent to angle FGD. All right angles congruent. That's where my second pair is coming now. Not reflexive, but all right angles congruent. Now you have 2 pairs. Can you guys finish this off in 5 steps? Can we finish this off? What's the next step? Now you're going to do what with the angles? Now subtract them. Okay, now subtract your angles in the correct order. Bigger ones first. ABD minus, let's see, look at your diagram. I should take ABD and subtract ABC and do the same thing on the other side with right angle FGD. Subtract FGE. Always need two pairs, and I only gave you one. And where'd the second pair come from? Your right angles being equal. Always forget when this one ends. And then always what's after subtraction, addition, substitution. To plug in the prove angles. DBC is congruent to DGE. Questions? Anything at all? Going? Are we okay? Subtraction and why I needed to put in the right angles because that was my second pair I needed to subtract. Getting a little tougher. Okay, getting a little tougher. Okay, this is an on your own one. This is an on your own one. I'm not going to give you too long to do it. Guys, boom, what do you see?
Bisector.
What do you guys see?
Bisector.
Bisector. What's going to be the last statement reason in your proof? Halves of equal quantities. This has, guys, this is just review. Does anybody see anything about perpendicular lines or right angles? No, so it shouldn't come up in your proof either. This is just halves of equal quantities. Make sure you got everything in your checklists. I'm not going to tell you how many steps this should be. This is halves of equal quantities. Do you have a pair of equal or congruent quantities? Yes or no? Do you have the halves written out? Yes or no? Yes, this is tough. Just our standard halves of equal quantities. Before you're done with the proof, do I have a pair of equal quantities? Check. Let me know. Did I tell you what I'm taking half of? Good work, guys. Good work. Once I have all that, then I can write they're equal by halves of equal quantities. I'm going to get going just because I want to make sure we get to the last problem too today. Do you have a pair of equal or congruent quantities? That was given to you. Check. Did I write down what I was taking half of yet? No, that's statement number 2. You're going to take half of one of the two angles that are congruent, EAB. And in this case, I'm going to call it angle 1 because that's the one in the problem. I could have called it GAB, but that's not part of the proof. And I'm also going to tell you I'm going to take half of the other congruent angle, FBC, and set that equal to angle 2. Definition of bisects or bisector, that's fine too. That's how I knew I was going to take half those angles because it said it was being bisected. All right, I got everything I need. Now 1 and 2 are going to be congruent because I just took halves of equal quantities. Okay, questions? Anything from you guys? Standard halves of equal quantities proof. And hopefully you guys are starting to see, hey, it's I pretty much have to do that step myself. It's going to be pretty rare I give that to you. All right, I'm going to have to do the half statement myself. All right, so we're good? All right, last one. I just wanted you guys to be aware I am going to ask you to still do some algebra problems for me, just not proofs. I know it says given. Up here, I know it says given, but look at the directions. Everyone see this word here? Does it say prove? Okay, so no statements, reasons needed. If it just says find, tell me what the answer is. Okay, this is an algebra problem. I don't need statements, reasons at all if it says find. If it said prove, then yeah, but it says find. RST, perpendicular to SQ. Let me start with somebody. I should put a right angle symbol where? I see perpendicular, that means right angle. So where should I put a right angle symbol? Name the angle. 2, Karen, any idea where the right angle should be? Where does RST and SQ meet? RSQ should be a right angle. Done. There it is. And RSU, that should be 89 degrees. Plop that there. Okay, I got a couple questions for you. Let's find the measure of RSQ first. Karen did all the work for everybody. Now somebody just clean it up. RSQ, 14. Nope, one more. 12. Luke, RSQ is going to be 90 degrees. Good work because I put a right angle there. Bad news, though. Bad news. I didn't mention this yet. Everyone see the bold here? Justify your answer. That means right next to it. How do we know? Luke, how'd you know it was 90?
Because it's a right angle.
Right angles equal 90. Perpendicular lines form right angles. I'm going to be pretty flexible on the reason here as long as it makes some sense. So right angles equal 90, that would be fine. But you got to come up with some type of reason why you got that answer. That's what justify means. Okay, write a little something how you know. Okay, how about QST, everybody? QST? What about Q to S to T? What do you think there? QST? How many degrees? 17. Emma? No, you know it's 90 degrees. How do you know that?
It's part of the perpendicular.
All right, so I'll write perpendicular lines form right angles. I could have also just copied right angles equal 90 there. Anybody else want to throw another one? I'm pretty flexible here as long as it's kind of in the ballpark. All right, we got a couple more minutes. Perfect. TSU? Anybody? TSU. I already know that's 89 next to it. So TSU, not 90. That's not forming a right angle there. Whew, 1, George.
Whatever.
Oh, here we go.
180 minus 89 is?
Oh, you mean 91? Why'd you do the 180 thing? How did we get to 91?
Because straight lines are equal to 180.
Fine. Straight angles measure 180. Anybody want to put anything about supplementary angles equal 180? Perfect. Okay, I'm pretty flexible here, but you just got to be in the ballpark with your reason. Okay. Questions from you guys? So tonight on homework, yes, there's a couple proofs, but there's also find, which means just do it algebraically. All right, great job today. Good work. Stop in if you're having issues. Tuesday's coming quick, next Tuesday.